All right, this is for the intro to implicit differentiation. So it says an implicitly defined curve. It's a function that cannot be written explicitly as a function of x. So that means you have a combination of x's and y's or different variables, in most cases just x's and y's, and you are unable algebraically to get y by itself so that it's in the form y equals and all of the other variables are on the other side. So what we're going to learn today is how to find the derivative of a function like this where the x's and y's are all mixed up. Now I want to remind you that y represents the function in terms of x when we write the letter y. And then when we take the derivative of y with respect to x, that's also called f prime of x. So when we see an equation like this, and I want to find the derivative, so over here I'm going to write dx. That's saying I'm going to take the derivative of this function with respect to x. So what that means is all of these derivative rules that we have learned apply directly with an x, but if we see a letter that is not an x, we have to treat it as though it's an unknown function. So let me go through this with you, and then I'll also show it a different way in case it doesn't make sense. All right, so the derivative of x is just a 1. Now, y, because it's not an x, I have to treat it as if it's a function all by itself. So if this is an unknown function, I actually have to do the chain rule here. So I will take this 2, move it out to the front, and then I change the exponent here to a 1, and then I have to write in what was there in the first place. Now the derivative of y is dy dx, and I have to multiply times the derivative of y, which is dy dx. So now if I just rewrite this so it doesn't look so crazy, I'm going to put 1 equals 2y times dy dx. But my goal is to find dy dx, so I have to get dy dx by itself here. So I'm going to then divide both sides by 2y, and my final answer is dy dx equals 1 divided by 2y. Now, if it helps you, I'm going to solve this another way. Instead of writing y, I'm going to write f of x, and that is being squared. Because we have up here that y is f of x. It's a function of x. So if I take the derivative with respect to x, the derivative of x is a 1. Oops, I want to use blue. It's a 1. And then here, we're going to do like we did with the symbolic manipulation. So I have to use chain rule, move the 2 out to the front, keep the inside function the same. The exponent becomes a 1. You don't have to write it. And then I have to multiply times the derivative of the inside function, which is f prime of x. F prime of x is the same thing as dy dx. So to get f prime of x by itself, I'm going to divide both sides by 2 f of x by 2 f of x. So I get f prime of x equals 1 over 2 times f of x. And just for simplicity, I'm going to replace f of x with a y, just like that. All right, so here's example 2, and I'm going to do the same. I need to find dy dx, so I'm going to take the derivative of this function with respect to x. And that means everywhere that I have a y, I have to treat it as an unknown. All right, sorry, I had to visit you. Okay, so here we go. All right, so 2 times, and I have to treat this as a function, so it's going to be 2 times, well, the derivative of y is dy dx. Now, I'm taking the derivative with respect to x, so this term, we just treat it as we've been, so it's just going to be 2x. All right, now here, I have to take the derivative of cosine, but I have an unknown function on the inside of y, so I have to treat it like chain rule. So the derivative of cosine is negative sine. I keep the y, but then I have to multiply times the derivative of y. That's applying the chain rule, which is dy dx. All right, so now I have a dy dx term over here, and I also have one over here. So what I want to do is I need to get my dy dx's on the same side of the equal sign. So I'm going to add the negative sine y times dy dx over to the left-hand side of the equal sign. So I get 2 dy dx plus sine y times dy dx equals 2x. Now, since I have a dy dx in both of these terms, I'm going to factor that dy dx out. So if I factor out a dy dx, I am left with 2 plus sine y equals 2x. And my goal is to have dy dx by itself. So I'm going to divide both sides by 2 plus sine y. So my final answer is the derivative of this function up here is 2x divided by 2 plus sine y. All right, this last one is kind of a bear because I have two functions being multiplied together. I have 3x times y, so that requires product rule. And then I also have another one over here that also requires, I have an x times y squared, so that's also requiring the product rule. So this is going to take a while. All right, so I want to take the derivative of this entire function with respect to x. All right, so for this one, 3x is my u and y is the v. And product rule, u times v prime plus v times u prime. All right, so u is 3x, so that stays 3x times the derivative of y is dy dx plus v, which is a y, times the derivative of u, which is just a 3. So this one's now done right here. So I've got plus. Now here I'm going to let x be the u, y squared be the v. And again, I'm applying the product rule here. So u times the derivative of v. So I have to treat y as if it's an unknown function. So I have to use chain rule here. So it's going to be 2 times the y, and it becomes a 1 exponent. Then I have to multiply times the derivative of this inside function, which is y. So dy dx. And then plus, so there's u times v prime plus v, which is y squared, times u prime, which is just a 1. And the derivative of 7 is a 0. All right, so I got a lot of stuff there. So what I want to do, I want to clean this up a little bit, make it look a little better. So let's see, this is 3x dy dx plus 3y. Over here, I have plus 2xy dy dx plus y squared equals a 0. I notice I have a dy dx here and a dy dx here. I want to group the dy dx's together on one side of the equal sign and move all the other terms to the opposite side of the equal sign. So I'm going to keep 3x dy dx plus 2xy dy dx. And I'm going to subtract the 3y and subtract the y squared. So that becomes minus 3y minus y squared over here. All right, now that I have only dy dx terms on the left side, I'm going to factor out the dy dx. And I'm left with 3x plus 2xy equals negative 3y minus y squared. So to get dy dx by itself, I'm going to divide both sides by 3x plus 2xy. And I can see these then cancel here. So dy dx equals negative 3y minus y squared over 3x plus 2xy.